All right, so we'll finish up. We'll do some more example problems out of the stuff that we were talking about last time. Doing some applications with doing right triangle trigonometry stuff. And then they'll do the quiz the last 15, 20 minutes of the hour. And when you're done with the quiz, you can turn in. Done. So, all right. So last time we talked about the different ratios that give us the different trig functions. So our goal here in these particular problems is to set up a triangle and identify which ratio we want to use so that we know which trig function that we want to use based on the information that we're given. So we've got, in this problem, a telephone pole broke during a storm. Top part comes down and touches the ground. That part is 48, a little over 48 feet from the base of the pole. The top of the pole makes an angle with the ground, and then it wants to know how tall the original telephone pole is. All right, so we'll assume that the pole was at a right angle with the ground to start with. Otherwise, we're going to have issues. Right. So the pole goes up and goes this way. We know that it touches the ground 48.3 feet from the base, and we know that it makes a 26.6 degree angle with the ground. And it asks us how tall was the original telephone pole. If we want to know how tall the original telephone pole is, what do we need to figure out? The length of the sides, good. Yeah, we need to figure out what the length of this side is. I'll call it C. The length of this side, call it B. Doesn't matter. We need to figure out what the lengths of those sides are, right? Because the total is going to be the height of the pole originally. That's what's making our triangle, right? Okay. So let's say we wanted to figure out what B is first. Okay. So I wasn't interested in C at all. We wanted to figure out what B is. What ratio might we want to use? What trig function might we want to use to be able to figure out what B is? Why'd you say tangent?
Because you take tangent of 26.6, and we know the adjacent side.
Good. Yep. I know that tangent is opposite over adjacent, and I know what the adjacent side is, right? Agreed? So if I want to figure out what this B is, I better not use the C because I don't know what C is yet, right? So when we're just trying to figure out B, we want to know what we would want to know what. Sorry, we want to use the tangent. So we set up the equation of tangent at 26.6 degrees is B over 48.3 because we're doing opposite over adjacent. We can solve for B. And now this becomes a calculator active problem if we want to actually get a decimal approximation. This one's asking us to round to 2 decimal places. So again, like I mentioned last time, when you're doing things with your calculator, I don't have a calculator with me today, or at least not one I can put up the screen. When you have your when you're using your calculator, you either need to make sure that you're in degree mode, for this one since it says 26.6 degrees, or if you want to leave it in radian mode all the time so you don't get confused, you can and not worry about whether or not to switch it back and forth. You can always convert from degrees to radians by doing what? Yeah, you can always multiply by pi over 180, right? Which is exactly what I'm going to do on this particular calculator because I don't know how to change it from radians to degrees. I just pulled it up a minute ago. So we want to do 48. Go away. 48.3. And then I'm going to need sine of 26.6 times Oh, I did put it in degrees. That was weird. I don't know why I put it in degrees. That was bizarre. I don't even know how I did that. It just entered it and said it was going to be 26 degrees. Of course, I don't want 26. I want 26.6 anyway. Oh, we were doing tangent. Thanks. That's probably important. Stop opening up other stuff. Tangent. Well, I thought this was going to be more convenient. It definitely is not. 26.6. You know, I might be doing it in degrees anyway. Let's see if it does do it in degrees. Nope. Definitely not degrees. Wow, that was super faster, wasn't it? Let me just tell you what those are. Get my calculator out or my phone out and do it that way. Enter. What are you doing? What value did you get? Did you get 24.18? 19, I guess, if I round it right. Like I said, that was super faster. I'll just let you guys tell me what's going on. No, I forgot what the number was. What was it again? Thank you. And that'll be feet. That's just for the opposite side. All right, I definitely have to bring a calculator with me next time because that was not convenient. All right. Let's ignore the B now, and we wanted to solve for the C. If we just wanted to solve for C, what trig function would you use? Yeah, cosine, and why did you say cosine?
Because you have the adjacent side.
Good. Yeah, we say cosine because we have the adjacent side, and we're looking for the hypotenuse. All right, so cosine will work nicely for us there. If you use cosine, what would your equation be? Good. Yeah, 48.3 over the C, right? So notice the variable's in the denominator in this case rather than the numerator. So we're going to need to multiply both sides by C and then divide by the cosine of 26.6 and get 48.3 over cosine of 26.6. Like I said, I'll let you tell me what that is this time. 50 point, did you say 0.02? Okay, cool. One thing that you should notice, if I look at this particular number, this should be the biggest side of them all, right? Because that's the hypotenuse. Agree? That should be the biggest one, which it is. Also notice that this side that's across from the 26.6 is smaller, and it should be, because if this is 26.6, this one's going to be 63.4, a complement, right? And if I'm going to have the side across from a larger angle, it better be bigger. So the numbers are making sense. Just kind of a quick check to make sure the numbers are making sense as we go across there. Does that make sense? And then finally, it asks us what the height of the original height of the telephone pole was, and what you do with those two numbers. Add them up. Yeah, good. So you get 78.21. All right. Good with it? Good with that one? Okay, cool. All right. Let's look at the next one. Got a tree on a hillside. Conservationist is trying to figure out how tall the tree is. 75 feet away from the tree, down the slope. Figured out angles of elevation to the top and the bottom of the tree, and then wants to know what the height of the tree is. So this gives an opportunity to define what we mean by angle of elevation. So let's say that this is the slope, And we've got a tree here. Conservationist is this direction. Okay. So this length would be 75. That is ugly looking 75. All right. It says that the angles of elevation to the top and the bottom of the tree are those two particular angles. So when we talk about angle of elevation, we need to know we're talking about an angle off of the horizontal. Okay. Angle of elevation is if you were looking straight out horizontally, and then how far up would you have to look? That's angle of elevation this way. Okay. So we need a horizontal and go up off of it. Okay. It says that the angle of elevation to the base of the tree is 28 degrees. So that tells me that this angle right here would be, 28 degrees. It's always measured off of a horizontal. So since it says the angle of elevation from or to the base of the tree is 28, I need to go horizontally up the hillside is 28 degrees. That's pretty good slope, actually. It also says that the angle of elevation to the top of the tree is 56. Does that mean that this angle is 56? The one that's in that triangle? No, again, it's always measured off of the horizontal, right? So it means that this entire angle here, that big angle would be 56 degrees. So far, so good? All right, let me draw this off to the side over here just to make a different picture. So I've got a right triangle this way. Well, I'm going to make a right triangle this way. Or I've got another piece coming off this way, all right? So I see a smaller right triangle and a bigger right triangle if I continue this down this way. We're trying to figure out what that side is. I know this side is 75. I know this angle is 28. And we know that the big angle is 56. I am not having a good writing day. I mean, I don't typically anyway, but... Okay. What might be your plan of attack here to figure out how tall the tree is? I think it's going to take us a couple of steps to get there, but what might be your plan of attack to figure out how tall that tree is? Yeah.
Subtract the 20 from 56 angle at the top.
Okay, that's true. I could find this angle here. That one. Oops, not 280. This certainly would give me that angle.
We need to find like the size of the smaller triangle.
That would probably be one thing that would help first is find a smaller triangle to give me this side here and this side here. Right? That might be some helpful information. Let's go ahead and do that. Let me draw that triangle by itself. This is 75. This is X. This is Y. This is 28 degrees. I labeled them X and Y. I don't really care what you labeled them. I mean, you could draw pictures of emojis if you want to. I don't care, as long as you know what they mean. Use Greek letters. Use your favorite Pokemon characters. I don't care what the variables are. What equations would you set up to help you figure out what X and Y are? So the sign would give you which one? The y, good. So what equation would you set up for that one?
Sine of 28 degrees equals y over 75.
Good. So I can figure out what the y is by using the sine ratio, opposite over hypotenuse, multiply by 75. And what do you get for that one? 35.21. Okay. So that's, well, we'll say approximately equal to 35.21 on that one. We can also figure out what x is about. What ratio would you use for x? Cosine? So you have cosine of 28 degrees is equal to, good. Very similar equation, right? We're just using the adjacent side rather than the opposite side. Solve for your x. Solve for
6.22.
Thank you. I think this is a good first step. It gives us more information about that bigger triangle than we were just talking about. And I still need to figure out what the height of the tree is, right? Don't lose sight of the forest because of the trees. I think I have a tree. Yeah.
Could you use the ratio that we just got, the big triangle?
Okay, so what would you use?
B over A.
So if I look at the big, talk about the big right triangles that we're saying. Okay. So like this one here. So what pieces of that big triangle do you know?
We know A or X.
The A or the X, either one, right? I know that this is roughly 66.22 here, right? What else do we know? I know the little part of the Y, right? But I don't know the whole side. Yeah, so I will call this one B to give it a different letter. We'll need to use that Y in a minute, though. You're exactly right. What else do we know? Yeah, good. 56 is the angle, right? We agree with that? Okay. Now what ratio would you use? Tangent. Good. Yeah. So tangent of 56 degrees is equal to?
B over 66.22.
Good. Yeah, 66. Yeah, B over the 66.22. Now, one thing I would make sure that you do in your calculators is don't round. It's okay if you round on your paper as you're showing your work, but don't compound rounding errors by rounding it and then typing in the rounded number. Make sure you keep all your digits in here. Right. There's a couple of ways to do that. You could use your previous answer button on your calculator. That's a good way to do it. There's also storage in your calculators. You can store the variables in there using any of the letter names that you have. If you're unsure how to do that, I can show you another time. The other way is literally just retype in where the 66.22 came from. There's where the 66.32 came from, right? Or 22 came from. Just type in 75 times cosine of 28 times tangent of 56. Moral of the story is don't use rounded numbers and then do new computations. Okay, keep all your digits in your calculator. Otherwise, you'll just compound rounding errors as you go. What do you get for that value? Roughly 98.18. Is that the value we want? Nope. What do we need to do with that value now? Yeah, subtract the y, right? That 98.18 is that entire distance, right? So your tree height will be 98, approximately, I should say. Approximately 98.18 minus 66.22, which is what, 31.96 feet? Oh, I did that wrong. I subtracted the wrong number. Sorry. I subtracted the x instead of the y. Minus the 35 gives you what? 62.97? Did I do it right that time? Okay. I saw one nod, so I'll take it as a yes. That one okay? All right. See if we can do one more here, and then we'll take the quiz. It says two observers exactly 1 mile apart observe a glider over a line directly between them. Actually, that says between of them. Apparently, I got a typo. Sorry. You've got angles of elevation from each of the observers, and it asks what's the altitude of the glider. All right, so glider's up here. You got a 48.2 degree angle of elevation here, a 36.8 degree angle of elevation here, and you know that entire distance is 1 because they're 1 mile apart, and we're trying to figure out the altitude here. I'll call it h for height. Like a decent setup for what we have. All right. The issue is, at least I think what the issue is if we're trying to figure out what this height is, we're looking for an opposite side no matter which angle we're looking at, right? We don't know the adjacent side for either of them or the hypotenuse, do we? Let's break it into two pieces, though, and see if we can work on this, because we really do have two right triangles, don't we? So let's call this side over here x. Let's call this side over here y. Give me two equations here involving right triangles that include some of the variables that we need or need to solve for here. Give me two equations to start with using trig functions. They'll have two variables in them. I just was looking for two equations. Good. Tangent of 48.2 is h over x, and good. We agree? So far, so good? Okay. Those are just the ratios, right? We have opposite over adjacent for each of those two angles. Okay. The issue is that I've got two equations, but how many different variables do we have that we don't know? We got three, right? I got an h, an x, and a y, right? Typically, if I need to know information, or if I want to try to solve for a certain number of variables, I better have that many equations, right? If I have 3 variables, I better have 3 equations. Right now we only have 2. However, there is a third equation that we can come up with that doesn't involve h at all. Now, what is it?
Let's say x equals 1 minus y.
Yeah, the x and the y have to add up to 1, don't they? That's one more piece of information we have. So we also have that x has to be 1 minus, or I'll just write it this way. X plus y has to equal 1. That's a third equation. Now we have 3 equations and 3 unknowns. We should be able to figure out what this answer is, right? So what plans of attack might you have to be able to do that?
This is probably dumb. Maybe like x equals 1 minus y.
Okay. Do that. Okay. And then,
Y equals 1 minus.
okay, so we also get y equals 1 minus x as well. Okay, so what might you want to do with one of those? Yeah, put it in one of the tangent equations, one of them, right? So I know that the x is 1 minus y. So maybe we can put it in this one. Oops. So now I've got 2 equations and 2 unknowns, don't we? All right. So now what might we try? What did we do here? What do we do from here to here?
Solve for x.
Yeah, solve for one of the variables in terms of the other, right? So what you might want to do with one of these equations?
Solve for
Yeah, you can solve for h or solve for y, either or, right? We solve for one in terms of the other and substitute, right? Let's do the exact same thing. Solve for one and substitute for the other. Let's clean this up a little bit so maybe it won't make something so nasty. Let's clear our fractions. This is 1 minus y tangent of 48.2 degrees equals h. This is y tangent of 36.8 degrees equals h. Right? Just cleaned up the fractions. Yeah. Okay. So we've got both things are equal to h here, so we could set them equal to each other. That solves for y, doesn't it? But do we want y? I mean, we can figure out y and then figure out h. But we really want h, don't we? That's what we're trying to get to. So let's solve this one for y. And then substitute it into the other one. And that will be able to give us an equation just with h in it. Right? So here we got rid of the x by solving it for in terms of y. This one we got rid of the y by solving it in terms of h. And then finally, we can go over here. And now we have an equation that just has h in it, don't we? It doesn't look pretty, but it is just an equation that has h in it, doesn't it? Okay. What would we need to do to solve for h? Yeah, distribute through. Yep, distribute it through. Move all your h's. Right? So let's distribute the tangent of 48.2 through. Do that over here. So we'll have tangent of 48.2 minus h times tangent of 48.2 over tangent of 36.8. That's equal h. Yeah, it doesn't look horribly pleasant, but those tangents are just numbers, right? That's all they are. They're not the prettiest looking numbers right now, but they're just numbers. What do I need to do next? Yeah, move the h part to the other side, don't we? Tangent of 48.2 degrees equals h plus h times that other mess. What's next?
Multiply by tangent of 48.2 over tangent of 36.8.
I think I want to do something else before I do that because I've got an h in each term here.
Oh, yeah.
So what do you want to do first?
Factor it out.
Yeah, let's factor out the h, right? It's like combining like terms. And then to solve for h, what do we need to do? Yeah, just divide what's in the parentheses, right? Exactly. This is just, it's messy, but it's just a simple algebra problem, right? Not the prettiest algebra problem in the whole world, but it's straightforward, just a linear equation that we're trying to solve, right? It's just your numbers look ugly, don't they? But the actual algebra part to solve it is pretty straightforward. You've got x's on both sides, so you combine them, right? You moved them all over to one side and combined. Okay. And then now that looks like a nice problem for a calculator. Because I ain't doing that by hand. I do want to give you time to take your quiz here. Make sure we have plenty of time. It's not long, it's just the one side. But I just want to make sure we all have the same time. Are there any questions at all over this before we do the quiz? Great. So like I said, just the one side, just a short quiz over that first section that we talked about. Make sure that we're all on the same page with those things. And when you're done, you can go.